Okay, so now we need to create some shell code. So let's start by restarting, since we're here. Delete this file and restart. Put it online. Let's reset our breakpoint, make sure it's set. Okay, so let's create some shellcode. Pop back over to Kali, and we are going to use MSF Venom. We can use any payload that we want for Windows. I like Windows shell underscore reverse TCP or underscore bind TCP. So it is going to be inline, so we don't have to use a Metasploit handler. We can just use netcat, since we don't have to deal with the staged payload. So let's do, bind TCP works. Okay, so then we don't actually have to set any options. If we do a -O, it'll show us the options, but we can just let it do the default port of 4444 if we like. And we do need to give it the bad characters. That's going to be -B. And our bad characters, we do need to tell it the space as well. We have 607 characters to work with. Remember, we found that in MonaFind MSP. So we need -B and our list of bad characters, which I gave you, and -S 607. You can also do the format as Pi to have it automatically put it out in Python format, so we don't have to worry about formatting it. Alright, that looks good to go. Let that generate. It should be encoded, so it will need to decode itself first thing before it actually runs, because chances are some of those opcodes that we said are bad characters will be needed. So it did encode it with shikata, and it is size 368, so it does not take up the entire 607 characters. So we will need to pad it accordingly. So I'll just copy this and open up my warftpscale.py. Above buffer, I'm going to paste this in, and it's called buff. Since it already is put in Python format, I can just drop it in. And then right after my 4 C's of padding, before I put in my D's, I'll just put buff right there. So buff again was, how big? 368. So we will leave our D's in. So again, we have it as length of buffer. So just putting in buff here will make it automatically adjust how many padding D's it puts in. So I think that makes life a little bit easier. We don't have to do the math. Alright, so this should be good to go. You may find that it is in fact not good to go, but it should be, theoretically. We've done everything correctly. So let's go ahead and run it. We do hit our breakpoint, so everything's good there. So we can do our F7, and we should get to the beginning of our shellcode. So D9, EB, BD, A6. If we look here, D9, EB, BD, A6. So yes, that seems to have gotten us right to the beginning of our shellcode. So everything should be awesome, and it should decode itself into its original format, take it out of shikata, and then we should be able to execute it. Don't worry if your shellcode is somewhat different than mine. Shikata is polymorphic, so it's not going to be the exact same characters, so you need not worry entirely about that. Alright, so if we just let it run, it says it gets an access violation when writing to 00000001, and it's paused, so it did crash, and it looks like we're actually still in, or near the beginning of the shellcode. We haven't gone too far. Well, let's see. Since it crashed, my guess would be we actually don't have our listener, but we can try. But netstat A&O, and that'll tell us all our listening ports. 4444 TCP is not there, so this did not work. So something went wrong. Well, what went wrong, and how can we fix it? So this is going to be something that is going to come up. Not necessarily this particular situation, but there will be times if you just follow the script with exploit development, something won't work, and you can either, throw up your hands and give up, or you can try and debug it and see if you can figure out what's wrong. So that's why I like to start with an example like this, because it should be, oh, we're done, hooray. But in this case, something went wrong, and we are going to have to fix it, and I won't always be here to help. So let's go ahead and restart, see if we can step through this and figure out what's going on. So let's get rid of our extraneous file. Again, you don't need to do that if yours doesn't crash. Let's restart. Put it online. Reset our breakpoint. Make sure it's set. Alright, let's run it again. We definitely want that breakpoint because we are going to see what's going on with the shellcode. Run it again. Breakpoint, awesome. Let's do our F7s to get to the shellcode. Alright, so remember we are encoded, so it does have to decode itself. So my guess would be something is going wrong in the decoding because we're getting a crash. So if just one byte goes off, then it won't work. So let's look at what's happening here. It's actually this third instruction down that's our problem in this case, this FST-ENV, and even if you are familiar with assembly, you may not be familiar with this particular instruction. What this is doing, well, it's in the process of trying to find itself in memory so it can decode itself with our decoder, so it's trying to basically find out where it is so it can decode the shellcode. But what this particular instruction does is it writes, in this case, a 28-byte structure to the stack, starting at ESP minus C. So 9, 10 is A, 11 is B, 12 is C. So ESP minus 12. So it's trying to write, so 12 bytes above ESP, because again the stack grows to lower memory addresses. It's trying to write 28 bytes. So it has 28 bytes to write, and it only has 12 bytes before it hits ESP. So what might that do to our shellcode that's sitting at ESP? Oddly enough, this particular setup with Shikata sitting at ESP will actually, I guess, buffer overflow into our shellcode if you think about it. So it basically is only giving itself 12 bytes to work with, and it's using ESP as its base register. So again, if we do F7s to get to that one, now watch our stack right here. So our stack is the beginning of our shellcode at ESP. So if we execute the FST-ENV instruction, look at the first few bytes. So do our F7. Sure enough, the first few bytes of our shellcode get corrupted. Well, that's no good, is it? That's no good at all. So my guess is our decoder never finishes because it gets corrupted in the process of trying to set itself up. So that's a little bit unfortunate. It's just the way the decoder for Shikata works. But it's something we can certainly deal with. Once we have jumped to ESP and we've gotten to the beginning of our shellcode, there's really nothing to say we couldn't move ESP somewhere else. Our Shikata decoder is going to use ESP as its base when it's trying to find itself, but it doesn't have to point at the beginning of the shellcode. So why don't we just move ESP? We can probably figure out how to do the assembly for that. It seems like it should at least fix this particular problem. So let's restart while we're here. Alright. Set our breakpoint as well. And what we're going to do is go to user share metasploit-framework and tools. And I'm going to open up metasm_shell.rb. So this is a rather nice tool that allows us to create opcodes from assembly without having to compile everything with NASM and whatnot. So I think it's fairly useful to get our opcodes from our assembly. So we'll open that up. It is a Metasploit tool. And so we want to move ESP. I want to get it far, far away from my shellcode. So if I add to ESP, that'll move me down the stack, and chances are it will still be in our shellcode. So I would like to subtract from ESP. So sub is subtract. In Intel format, the destination comes first. So subtract from ESP, comma, the amount we'd like to subtract. Let's say, how about 1500 bytes? That's certainly more than we need, but let's get it far out of the way. Well, there's just one problem with this. It's got null bytes in it. Nulls are a bad character, so we can't use those. So we're going to have to do something else. We could do, like, maybe subtract ESP. What if we did, like, 200? Still null bytes, so let's see. 50? That might work, but we have another option here. How about, what if we do a logical equivalent? What if we add to ESP, instead of 1500, negative 1500? So we do the equivalent of subtracting. That doesn't have any null bytes in it, so why don't we do that? Let's copy this. And I'll exit Metasm, go back to my desktop, and open up my warftp. And I just want to put this right before the shellcode starts, so right before we start decoding, I'll just move ESP out of the way. The shellcode will not be affected, and that should hopefully, when that fstenv occurs, it'll keep that structure away from our shellcode, since we've moved ESP out of the way. Oops, it already had quotations around it, so when I copied it, I already had quotations there, so I got double quotations, so I had to take those out. And it had buff equals empty string at the beginning of our shellcode. That's just how MSFNM put it out, so I could just put that there. So again, this is not going to be necessary every time. This is just particular based on the fact that it used Shikata Ganai and it was sitting at ESP, so this is one particular instance of shellcode crashing that you may run into. It will happen other times if you use ESP. Certainly this could happen again, but it's not the only way shellcode can crash. Really what I'm trying to show you here is that you shouldn't just be afraid of, oh, all this hexadecimal stuff, I can't figure out what's going on. Actually, you know, if you just look through it and spend a lot of time Googling about the stuff you don't know, like fstenv. When I first ran into it, I was like, I have no idea what that is. And I had done some assembly before. It's, you know, not add, subtract, pop, push, move, ones you see all the time. So, I mean, I had to Google it, but, you know, just Googling it, you know, stepping through it and seeing that corruption, I was able to figure out what's going on. And you can too. So it may take some time and effort, but it shouldn't scare you. Alright, so let's, as I'm saying, you can definitely fix stuff. Maybe I should check and see whether it actually works. So let's go ahead and run it again. We hit our breakpoint over here. Let's do our F7s to get to the beginning of the shellcode. So fstenv is still there. It's just the fourth instruction instead of the third, because we have add ESP -5 DC, which one can only assume that's some sort of hexadecimal representation. Alright, so let's do an F7 of that. So here's ESP now, pointing at the beginning of our shellcode. Now if we do an F7, ESP moves, and now we're nowhere near our shellcode on our stack. So if we let it run now, see if it in fact fixed our problem. So I just hit run or the play button, and it's now running, so it didn't crash. And if I take a look at netstat-ANO, sure enough, port 4444 TCP is now listening. So I can do a netcat 76, I think, 4444. Sure enough, we have a shell. If you used a reverse payload instead, if you did like Windows shell underscore reverse underscore TCP for the inline reverse, you would need a netcat listener. You could do like interpreter reverse TCP, but then you'd need to set up multi-handler. So I mean, you can use any Windows payload. It should be able to fit in 607 characters with only 4 bad characters, so it should be good to go there. So you're welcome to try a different payload if you like. So there is going to be an exercise, so you will have a chance to do another example in the next section.